Okay, let's unpack this. We've all seen the car chases in movies, yeah. Those impossible shots fired from moving vehicles, seemingly defying every law of physics.
Right.
But what really happens when bullets meet high speed, the complex forces of physics, and the unpredictable chaos of a highway? Today we're doing a deep dive into exactly that. The forensic analysis of vehicle ballistics at highway speeds.
Mm-hmm.
This isn't just an action movie scene. It's an incredibly challenging puzzle for forensic experts. And it's a crucial area for legal interpretation, too.
That's exactly right. This isn't just about raw speed. It's about this intricate dance of relative motions, surprising environmental factors, and really complex trajectories, all of which make these incidents incredibly difficult to dissect. From a scientific standpoint, sure, but also crucially from a legal standpoint.
Right.
Our mission today is to extract the most important nuggets of knowledge from this fascinating material. We want to offer you a shortcut, really, to being well-informed about a highly specialized field, and one that's legally significant. We'll be focusing on a specific side-by-side shooting scenario, revealing how experts piece together what happened,
Okay.
and why those precise scientific nuances matter so much when someone's future might hang in the balance in a courtroom.
All right, let's start with what seems like the absolute basics of physics, but, basics that immediately get complicated at highway speeds. We're talking about the fundamental physics of moving targets, particularly relative motion and kinematics.
Kinematics, yeah.
Kinematics, for our listeners, is essentially the study of motion without considering the forces that cause it, just how things move. It's the dance, as you said, of dynamic targets.
Right. And the core concept here is relative velocity. It dictates how speeds combine or cancel out when you have two objects in motion. For instance, imagine two vehicles, vehicle A and vehicle B, both traveling at 70 miles per hour, same direction, parallel lanes.
Okay.
Their relative velocity to each other is 0 miles per hour. They are essentially stationary relative to one another.
Stationary.
Yeah.
Even at 70 miles.
Exactly. And this is incredibly important because it dramatically simplifies some aspects of the ballistics analysis for a forensic expert. It gives them a baseline.
Okay, here's where it gets really interesting for me.
Yeah.
What does a 0 miles per hour relative velocity actually feel like in this context?
Yeah.
And why is it so vital for forensic analysis?
Well, for a shooter in that scenario, it means that while the world outside is rushing by at 70, the perceived distance and targeting challenge between their vehicle and the target vehicle is drastically reduced.
Oh, okay.
It's almost like firing at a stationary target at a shooting range, for a brief window at least.
Right, that momentary stillness.
That's crucial for any potential accuracy. But what's fascinating is how quickly that illusion of stillness just shatters in other scenarios.
Like heading towards each other.
Exactly. If those two vehicles were moving towards each other, say both at 70 miles per hour, their relative speed adds up. That's a staggering 140 miles per hour closure rate.
Wow, 140 miles per hour.
And the core insight there is Hollywood lies. A real gunfight in those kinds of opposing high-speed conditions. It isn't some deliberate act of aiming. It's a near impossible blink-and-you-miss-it event. You have literally milliseconds to engage. Milliseconds.
Milliseconds. That fundamentally redefines intent in a courtroom, doesn't it?
Absolutely. It challenges claims of precise aiming or, a prolonged exchange of fire. How could you, realistically?
That truly reframes how we think about these events. So how do these extreme physical constraints, like having only milliseconds to react, how does that challenge witness accounts?
Yeah.
Or maybe claims of self-defense?
It makes them very difficult to sustain credibly.
In such fleeting moments, how difficult would it be to prove deliberate aim as opposed to just, say, a desperate last-second reaction? Especially when someone's freedom or a conviction might hinge on that distinction.
Extremely difficult. And it gets even more nuanced, even at matched speeds and directions, like our 70 mile per hour parallel scenario. Minor variations can instantly disrupt shot alignment.
What kind of variations?
Think about slight changes in the lateral distance between the cars. Maybe one drifts a foot or two, or the subtle road grade of a highway. Those slight inclines or declines.
Yeah, you barely notice them usually.
Or sudden braking, or acceleration by either driver, even a tiny tap on the brakes. Each of these introduces a jolt, a shift.
Right.
And what's crucial for legal cases is that these seemingly tiny factors introduce significant uncertainty into any forensic reconstruction. It raises a core question for investigators and ultimately for the court. How can we establish precise shot geometry for a legal case when so many small things are constantly shifting the shooter's platform and the target's position?
And this connects directly to that legal concept of reasonable doubt, doesn't it?
Mm.
Or just the sheer difficulty in establishing a precise sequence of events in these dynamic incidents.
Absolutely.
A slight change in trajectory from a bump in the road could mean hitting the target, missing completely, or, tragically, hitting an unintended third party.
Mm-hmm.
So even seemingly minor environmental factors can have major evidentiary consequences. They could alter the entire legal narrative of intent or negligence or recklessness.
Precisely. The physics is the evidence in many ways.
Okay, so the bullet's out of the barrel. Now what? It's not just flying in a straight line, is it?
Oh, definitely not.
We're talking about external ballistics.
Yeah.
For our listeners, this describes everything that happens to a bullet after it leaves the muzzle. Beyond the internal forces of the gun, it's the bullet's journey through the air.
Precisely. Once a bullet is in flight, it's immediately affected by a whole host of factors. You've got wind drag, obviously, constantly working to slow it down. There's bullet stability. The bullet is designed to fly straight, nose first, right. But it might experience what we call yaw. That's a sort of nose up or nose down oscillation or pitch, which is more like a side-to-side wobble.
How does that happen?
Imperfections in the bullet, barrel wear, or just the air resistance itself can induce it. Then there's spin drift.
Spin drift.
Yeah, it's a subtle lateral movement caused by the bullet's rotation, much like how a spinning football might veer slightly off course.
Ah, never thought about that.
And even air density plays a role. It changes with temperature, humidity, altitude, and that affects drag. Now, compound all of that with the vehicle's motion itself.
Right, and that vehicle motion itself has a massive impact, doesn't it?
Absolutely massive. That's 70 miles per hour. Let's see, that's approximately 102.7 feet per second. That forward speed, it vectorially adds to or subtracts from the bullet's initial muzzle velocity.
Depending on the direction of the shot.
Exactly. Think of it like a swimmer in a river. Swim downstream, the river's current adds to your speed. Swim upstream, it subtracts.
Makes sense.
So if you fire, say, a 9mm bullet, typical muzzle velocity around 1,200 feet per second forward from a car doing 70mm.
Yeah, it's the speeds.
Right. The effective velocity relative to the ground becomes roughly 1,302.7 feet per second. Conversely, a rearward shot would subtract that 102.7 feet.
And a sideways shot.
For a purely lateral shot, like 90 degrees out the side window, the bullet's actual trajectory curves. It curves forward because of the vehicle's sustained forward motion vector as the bullet travels sideways.
Yeah.
It doesn't fly perfectly straight out.
That's a critical detail for forensics.
Yeah.
How does this altered velocity affect the bullet's potential, its energy, its penetration power, and therefore the risk it poses? Specifically, how does it influence penetration or maybe over-penetration, where it goes right through the target and keeps going, and the danger to unintended parties? From a legal standpoint, how can forensic experts accurately account for this altered velocity when reconstructing a scene? Say, to determine if the bullet had enough energy to pass through its intended target and hit someone else. That could lead to additional charges, like reckless endangerment, couldn't it?
Absolutely. It's fundamental to assessing risk and potential harm. And beyond those immediate velocity vectors, there are even more subtle forces at play, critically important ones. We're talking about gyroscopic drift and angular deflection. Gyroscopic drift. Because the bullet is spinning rapidly for stability, it experiences forces that cause it to slowly drift to one side, usually the side corresponding to its spin direction.
So that's significant.
Often negligible at short static distances, sure, but under high-speed dynamic shooting where the target window is tiny, even minor changes caused by this drift can easily lead to a miss. And what's really fascinating here is the constant shifting of the angle of departure. The angle the bullet leaves the muzzle and the angle of attack, the angle it hits the target. Because the shooter and target are moving relative to each other, these angles shift constantly. It demands that the shooter use what we call lead and offset to even have a chance.
Meaning they have to aim ahead of the target.
Exactly. They aren't aiming directly at the target's current position, but anticipating where it will be when the bullet arrives and also adjusting for their own vehicle's movement. It's incredibly complex mentally.
Wow. This really emphasizes the extreme level of precision needed for accurate forensic analysis. Even tiny shifts or these seemingly minor ballistic factors, they can mean the difference between a direct hit and a complete miss, or a hit that ricochets unpredictably. What does this complexity mean for investigators trying to determine the exact path of a bullet, and ultimately for evidence presented in court?
It means reconstructing a precise trajectory isn't just about drawing straight lines on a diagram. It's about modeling a highly dynamic three-dimensional event where even the air currents around the vehicles play a role. It makes establishing absolute certainty for a jury incredibly challenging. The defense can leverage that uncertainty.
So we've talked a lot about the bullet's flight, but what about the platform it's being fired from? Let's move on to vehicle stability and platform disruption, because it's not just the target that's moving, is it? It's the entire shooting platform itself.
Exactly. The vehicle itself is a constant source of instability.
So from a forensic perspective, what does this shaky foundation mean for shot consistency? How does it affect the evidence?
Well, it's an inherent compromise to accuracy. Think about it. You have constant vibrations just from the engine running, subtle oscillations from the suspension, even on smooth roads, and the shooter themselves can be jostled, even on what looks like perfectly flat terrain.
Yeah.
Now add to that any active maneuvers, sudden braking, even light braking, sharp turning, rapid lane changes. Any of that, and the point of aim stability is severely impacted, just gone. These factors mean that what might be a precise aim shot in a static environment, like at a range, is almost impossible in a moving vehicle. And the crucial insight for our listeners, especially regarding legal interpretation, this inherently reduces shot consistency, meaning that what might appear to be a miss in a static environment is almost expected in this dynamic one.
So what does this profound reduction in accuracy mean for the likelihood of precision shot versus, say, maybe a more general suppressive fire tactic, just trying to scare someone, maybe? And how does that distinction matter in a legal context? For example, if a shooter claims they were aiming for, I don't know, a tire, a specific non-lethal part of the car to disable it,
Right.
but the physics dictates a precision shot was virtually impossible. How did that challenge their claim of intent?
That's a fundamental challenge for the prosecution, or potentially a key point for the defense. In court, proving specific intent to strike a particular person, or even a precise point on a vehicle, becomes incredibly difficult, especially when the physical realities of the environment make such precision statistically improbable, utterly improbable, really.
So the defense could argue.
The defense could convincingly argue that given the inherent instability, any shot was effectively blind fire in terms of specific targeting, even if there was a general intent to, say, deter or damage.
Right, not aiming at anything specific.
Exactly. And this directly impacts potential charges. It could potentially move the needle from something like attempted murder down to reckless endangerment, depending on the jurisdiction and facts.
And that uncertainty, that inherent instability, it can be incredibly powerful in court. It makes it much harder for prosecutors to prove a shooter's specific target. It could impact charges like attempted murder versus reckless endangerment, or even bolster a self-defense claim, where the shooter might argue they were just firing in the general direction of a perceived threat without specific aim.
The environment itself becomes a key witness. The physics becomes a witness.
Yeah. The environment itself is testifying in a way. Now, let's talk about the window of opportunity, or maybe more accurately, the stunning lack thereof. We call it time on target. This isn't just about how fast the vehicles are moving, but about how incredibly little time the shooter actually has to engage.
You've hit on a critical point there. Let's use that extreme example from our source material again, the 140 miles per hour closure rate. Two vehicles approaching each other, head-on or near head-on.
Okay.
They are covering 205.3 feet per second, combined.
200 feet a second.
To put that in perspective, that's almost the length of an American football field covered every single second. Gone.
Wow.
So if a shooter has, let's be generous, say a mere 2-second window to react, identify the target, aim, and fire effectively.
2 seconds sounds like a long time, but at that speed,
It's nothing. That's only 410.6 feet of total engagement space. That distance is covered in the blink of an eye. It's an unbelievably short window.
that's an almost impossibly small window of opportunity. What does this mean for the shooter's ability to identify, aim, and fire effectively, even for a highly experienced individual?
It means it's extraordinarily difficult, near impossible without specific training and anticipation.
And what implications does this have for reconstructing the precise sequence of events in a legal investigation? It seems to suggest that any successful engagement under those conditions is more a matter of sheer luck or maybe pre-planning rather than a deliberate aimed shot in the moment.
Indeed. This extreme time constraint forces certain tactical realities. High-speed engagements often have to rely on ambush tactics, where a shooter might have pre-staged their aim.
Ah, okay. Lying in wait, essentially.
Or extremely close quarters tactics. Precisely because of this limited time, the core insight here is that Any successful shot in such a dynamic scenario often isn't the result of last-second aiming. It's much more likely to be a pre-planned or opportunistic act.
How so?
Well, a shooter might have to align their vehicle just right or pre-aim their weapon before the target even comes into clear view, anticipating its position based on speed and lane.
This linked back to legal considerations is crucial. How does this extreme time constraint affect the analysis of, say, premeditation versus a spur-of-the-moment action in a legal context?
It's a double-edged sword, legally.
How so?
Well, if a shot is fired in such a tight window, it could be argued that there was simply no time for deliberation. That could potentially support a claim of self-defense or acting under duress.
Okay.
Conversely, if the evidence suggests a pre-staged aim or maneuvers designed to create that ambush window, that could bolster an argument for premeditation or specific intent.
So the physics dictates what was even possible in that moment.
But exactly. And that physical possibility or impossibility profoundly informs the legal interpretation of the shooter's mindset and actions.
Finally, for this section, let's consider the vehicle itself, not just as a platform, but as a ballistic barrier, a highly unpredictable one, as you've hinted. What are the practical ballistic impacts when a bullet hits a moving vehicle? What actually happens?
Yeah, the vehicle isn't just a simple, uniform barrier like a paper target. Its components interact with bullets in incredibly complex ways.
Like the glass?
Exactly. Vehicle glass, whether it's laminated in the windshields or tempered in the side windows, it can cause bullets to yaw, meaning they tumble end over end as they pass through, or even fragment upon impact. This radically alters their trajectory after passing through the glass and affects their penetration ability.
And the metal parts? Doors, pillars.
Metal surfaces like doors, pillars, or the roof, they can cause unpredictable ricochets, or they can redirect rounds in entirely unexpected directions within the vehicle structure.
So hitting the door pillar might send the bullet somewhere completely different than hitting the door skin.
Absolutely. Inches can make a huge difference. What's crucial for understanding these incidents and for legal analysis is that shot placement is incredibly unpredictable. Unless, perhaps, one is highly trained in specialized techniques like vehicle interdiction or counter-ambush tactics.
Which most people aren't.
Which most people are definitely not. And even then, it's still a gamble due to the variables.
So the vehicle itself isn't just a target. It's this incredibly complex and unpredictable ballistic shield, almost.
That's a good way to put it.
What does this mean for shot placement and forensic reconstruction? And how does this inherent unpredictability complicate assigning responsibility for damage or injury, especially if a bullet ricochets and hits an unintended target, or causes damage far from the intended point of impact?
It means that a bullet striking one part of a vehicle can behave radically differently than one striking another part, even if they're only inches apart. The precise point of impact, the angle it hits at, the material struck, all contribute to a chaotic interaction. It's very difficult to model perfectly. This makes definitive trajectory mapping much, much harder than in a static environment, where you can often trace a fairly clean line from muzzle to impact.
So if a bullet's path is inherently unpredictable after striking a vehicle, given all the different materials, angles, internal structures, how does that impact legal liability for unintended harm?
That's a profound question for the justice system.
It seems like it raises the question, can a shooter truly be held liable for where a bullet ends up if its path was effectively randomized by the vehicle's structure?
It certainly creates significant hurdles for legal accountability and the burden of proof, especially regarding charges linked to specific outcomes versus the act of firing itself. That unpredictability becomes a central factor in the legal argument.
Now, let's take all those complex physics principles and apply them. Let's dive deep into a specific hypothetical scenario. The kind forensic experts might actually face in a real-world investigation.
Okay.
Our source material provides a clear setup for a parallel highway engagement. Can you walk us through the facts of this specific case study?
Certainly. The scenario we'll analyze is this. The shooter is the driver of an SUV. They're traveling in the right lane at a consistent 70 miles per hour.
Okay, SUV, right lane, 70 miles per hour.
The target is a sedan, traveling in the left lane, parallel to the SUV, also at a steady 70 miles per hour.
Got it. Sedan, left lane, also 70 miles per hour.
Parallel. The shooter's position is firing from their driver's side window, so the left side of the SUV. And the target area struck on the sedan is the rear right panel, behind the passenger door, near the wheel well area.
Rear right panel of the sedan. Okay.
And critically, both vehicles are assumed to be moving in the same direction at the exact same speed in adjacent lanes. And there's approximately 8 to 12 feet of lateral separation between them, typical highway lane spacing.
Right, okay. Here's our specific case study. What does this particular setup, same direction, same speed, parallel lanes, do to the physics we just discussed? What simplifications does it allow?
Yeah, this setup is key because it dramatically simplifies the initial analysis. It gives experts a valuable starting point.
How so?
Well, from a classical mechanics standpoint, remember, since both vehicles are traveling at the exact same velocity and direction, they are, for all intents and purposes, stationary relative to each other.
Ah, that zero relative velocity again.
Exactly. Which means the bullet behaves, at least initially, as if it were fired from a static position. We can temporarily set aside the complexities of forward motion impacting the bullet's lateral travel between the cars.
So it's like firing from a fixed platform at a fixed target. Just for that moment, the bullet crosses the gap.
In terms of the lateral component, yes. Assuming, of course, neither vehicle is accelerating, braking, or turning sharply during that split second.
So this relative stillness is a massive simplification that forensic experts can leverage. How does this help investigators narrow down possibilities? Or maybe establish a baseline for a legal process? It provides a crucial fixed point in an otherwise chaotic environment, doesn't it?
It provides exactly that, a geometric starting point. It allows them to focus first on the angle of the shot between the two relatively stationary points. Now, let's talk about the shot geometry and impact angle in this specific scenario. How do we unravel the line of fire? The first thing to consider is the shooter's orientation.
Right, inside the SUV.
It's a significant biomechanical challenge. The driver of the SUV has to rotate their torso awkwardly leftward. They're firing across their own body, probably one-handed, through the open driver window.
That sounds incredibly awkward and unstable.
It is. It's simply not a natural or stable firing position for accuracy. Not at all.
Imagine trying to do that at 70 miles per hour while simultaneously, keeping the SUV steady in its lane.
Exactly.
What does this awkward posture imply about the shooter's ability to aim precisely? And how does it introduce additional variables for forensic reconstruction? This isn't like standing comfortably on a firing range.
Not even close.
It's a deeply compromised body position that inherently degrades accuracy and control, which surely affects any legal arguments about intent or precision.
Precisely. Now, based on the target area, remember, the rear right panel of the sedan,
Yeah.
and assuming that typical lane width and lateral offset of about 8 to 12 feet, the bullet likely followed a rearward angled trajectory.
Meaning it wasn't fired straight across.
No. To hit that specific spot behind the sedan's center point from the driver's seat of the slightly trailing SUV, even if parallel, the shooter is physically behind the impact point laterally, the shot would have to be angled somewhat rearward. Let's say maybe 30 to 45 degrees back from a line drawn perfectly perpendicular between the cars.
Okay, I think I can picture that.
If you visualize it from a top-down view, SUV in the right lane, sedan in the left, both going 70 miles per hour, same direction. The bullet travels slightly rearward and left to right, from the SUV driver shooter to that rear right impact point on the sedan.
This provides critical directional clues for investigators then. Why is understanding this precise rearward angled trajectory so important, especially for determining the shooter's position and actions in a legal investigation?
It directly helps corroborate or refute witness statements, or even a shooter's own account of how they fired. Did they fire straight across? The evidence says probably not. It establishes a factual geometric basis for what occurred.
Right. It grounds the narrative in geometry.
And to truly grasp this complex geometry, a schematic diagram, specifically that top-down view or plan view, is invaluable.
For investigators and for presenting in court, I imagine.
Absolutely. Imagine looking down from above. You see the sedan in the left lane, lane 1, the SUV in the right, lane 2. You see that approximate 10-foot lateral gap. And the diagram clearly shows the bullet's path originating from the driver's side of the SUV, traveling diagonally, slightly rearward, to hit that rear right panel of the sedan. This schematic immediately clarifies the spatial relationship and relative positions. It's the absolute starting point for any detailed trajectory analysis in a forensic case.
So what does this all mean for someone trying to recreate this event for a court? A jury, maybe? How can they understand these complex angles and spatial relationships without getting lost in technical jargon?
This kind of diagram becomes foundational evidence. It's not just an illustration. It translates complex physics and geometry into understandable visual facts that anyone can grasp.
Okay, let's move into the real nitty-gritty now. Ballistics modeling for this specific scenario. What kind of bullet are we assuming was used, and why is that specific detail so important for the forensic analysis?
Right. For this analysis, we'll assume a standard 9mm full metal jacket bullet, an FMJ, fired from a handgun.
Okay.
We'll assume a muzzle velocity of approximately 1,200 feet per second. This is a very common round for law enforcement for civilian carry. It makes it a highly relevant and realistic example for a deep dive like this.
And why is knowing the exact bullet type FMJ versus, say, a hollow point or maybe a rifle round so important? How does that affect the forensic analysis, particularly when it hits vehicle components?
Oh, it makes a huge
I
difference.
can imagine different bullet types behave radically differently when they encounter metal or glass, right?
Yeah.
Affecting penetration, deformation, fragmentation patterns,
Yeah.
all critical evidence for reconstruction.
Absolutely. An FMJ is designed primarily for penetration. A hollow point is designed to expand upon impact, causing more tissue damage but potentially penetrating less through barriers. A rifle round has massively more energy, so yes, the bullet type dictates how it interacts with the target material.
Okay, so 9mm FMJ. Back to our 70 mile per hour scenario.
Right. Now, the bullet's lateral velocity, its speed sideways across the gap, is indeed that 1,200 feet per second muzzle velocity, roughly. And crucially, as we discussed, the vehicle's forward motion does not directly affect this lateral shot trajectory because the relative velocity between the cars is 0.
Okay.
The bullet's total velocity vector towards the target vehicle remains effectively the same in terms of its lateral movement component. However, and this is where it gets complicated again.
Always a however.
Always. Air drag and slipstream are still critical factors, even in this relatively static setup.
Slipstream. What exactly is that in this context? How does it affect a bullet?
Think of it like this. At 70 miles per hour, the air flowing around both vehicles, especially a larger, less aerodynamic vehicle like an SUV, generates significant turbulence. It creates a boundary layer of disturbed air and even partial vacuums alongside and behind the vehicles.
Ah, like the draft behind a truck.
Sort of, but it's turbulent. A bullet passing through the open side window doesn't enter perfectly still air. It enters this disrupted airstream, this invisible wake. And this turbulence can subtly alter its yaw, its stability, and its trajectory stability, even over that short 10, 12-foot gap.
So it's another example of where simplified physics gets complicated again. The vehicle's speed doesn't affect the lateral velocity component directly, but the air around it, moving because of the speed, still plays a role.
Exactly. Unseen forces are still at play.
How might this disrupted airstream manifest as actual evidence? Can experts detect it? And how does it challenge a clear-cut forensic reconstruction for legal purposes? Can you find, like, microscopic marks on the bullet or unique entry patterns?
Potentially, yes, though it's subtle. A forensic examiner might look for very subtle changes in the bullet's shape upon recovery, or perhaps minute residue patterns on the vehicle body near the impact that indicate this turbulent passage. But there's more. If the SUV's windows were closed when the shot was fired...
Firing through glass.
Yes, that adds even more variables. The muzzle blasts the expanding gases from the gun barrel and the bullet exiting a confined space. That creates increased back pressure on the shooter. It creates acoustic overpressure, an intense sound wave inside the car, and potentially muzzle gas distortion, especially if the firearm's muzzle is very close to the window edge when fired.
Muzzle gas distortion.
Yeah.
That's detail most people, myself included, would never even consider. What are the forensic implications of that? Can experts detect evidence of it?
It's difficult to detect directly long after the event, but...
How does it contribute to the overall unpredictability of the bullet's path? And potentially legal liability? It adds another layer of unknowable elements to an already complex scene, doesn't it? It complicates any claim of precise aim or intent even further.
It does. Think of it like blowing a smoke ring in a closed room, but much faster and more violent. The high-pressure gases escaping the gun's muzzle get momentarily trapped or deflected by the window frame or glass. This can subtly push the bullet slightly off its intended course, even before it fully leaves the vehicle's immediate environment. While it's very difficult to quantify perfectly after the fact, its possibility further underscores the inherent instability and unpredictability of firing from within a vehicle.
Right.
And that challenges any notion of absolute precision when arguing about intent in a legal setting. It adds another variable casting doubt on pinpoint accuracy.
All right, we've analyzed the complex physics of the shot itself.
Mm-hmm.
Now let's talk about the aftermath. What happens when that 9mm FMJ bullet finally hits the target vehicle? Specifically, the rear right panel of the sedan in our scenario. What did the physical evidence reveal?
Okay, the target area. The rear quarter panel of a sedan, it's typically curved metal, often around 20 to 22 gauge steel. That's quite thin, actually, roughly the thickness of maybe 2 or 3 credit cards stacked together.
That thin. Wow.
Yeah. And it's usually mounted over the rear wheel well structure, possibly layered with plastic trim on the outside or sound insulation on the inside. So it's definitely not just a flat, uniform piece of steel.
So how does the curvature and that thinness and maybe the layers, how does that affect how a bullet behaves upon impact?
Hmm.
What does a forensic expert specifically look for here to reconstruct the event,
Hmm.
to gather crucial evidence for a legal case?
Well, when struck by a 9 millimeter bullet at the velocity we're talking about, full penetration of that outer metal panel is likely. It's not armor plating.
Okay.
However, secondary fragmentation is possible. This means small pieces of the bullet itself, or maybe even fragments of the vehicle's interior components it hits after penetration, could break off, especially if the bullet hits internal bracing or suspension components hidden behind the panel.
Right.
Now, the risk of a clean ricochet back out of the vehicle is pretty low if the bullet enters cleanly. But yaw, that tumbling motion and deflection, can definitely occur within the panel structure itself or immediately after passing through, especially if it strikes at an angle, which we expect here.
This seems critical for understanding what happened inside the vehicle. What kind of fragmentation or deformation would indicate striking those internal structures, like the wheel well?
You'd look for unusual tearing of the metal, embedded fragments of paint or plastic in the bullet if recovered, or a trajectory path that clearly deviates after passing the outer skin.
And how does a forensic expert use this information to map the bullet's internal path? This mapping seems vital for a legal investigation, right? Particularly in determining the severity of potential injury to occupants or damage to critical vehicle systems like the fuel tank or brake lines. That could really influence charges of assault or reckless endangerment.
That's exactly right. The internal path tells a huge part of the story regarding risk and potential harm. And the impact angle is incredibly important here, too. As we discussed, the shape of the entry hole tells a story.
The elongated hole.
Yes. A shallower angle, which is what we expect in this side-to-side shot scenario, results in those elongated or oval entry holes rather than perfectly round ones you might see from a direct 90-degree impact. This unique shape immediately gives forensic experts crucial clues about the angle of attack, the angle the bullet hit the panel.
Okay.
And the terminal trajectory, where the bullet goes after entering, can then deflect downwards towards the wheel or upwards into the trunk, or even into the passenger cabin space, depending entirely on what internal structures it encounters.
So the shape of the hole literally provides critical directional clues. What precise details would an elongated or oval hole offer to an investigator trying to determine the angle of the shot and thus the shooter's position relative to the target at the moment of impact?
The degree of elongation, the aspect ratio of the oval, can be mathematically correlated back to the angle of impact.
Wow.
This is crucial for forensic experts to build a definitive timeline and spatial understanding for a courtroom. It can literally help them mathematically point back to where the shooter must have been relative to the impact point.
Okay, beyond the impact itself, let's reconsider the vehicle dynamics during the event. What specific challenges does the SUV driver, acting as the shooter, face? Challenges that complicate their actions and potentially their legal defense.
Well, as we touched on, the SUV driver is attempting one-handed firing, probably, from the driver's seat, often firing across their own body. That's an extremely unstable position to begin with.
Yeah.
Now, if they are also trying to steer the vehicle simultaneously, which they almost certainly are at 70 mile per hour, you can expect significantly reduced stability. You'd expect pronounced muzzle tilt or cant.
Can't, meaning the gun isn't held perfectly level.
Exactly. It's tilted sideways,
Right.
especially under recoil. And just inherent inaccuracy due to the constant vehicle vibration and the varying road texture itself. It's an incredibly unstable platform for precision shooting. There's just no way around it.
This reinforces that idea that precision is incredibly difficult. So how does this compromised shooting posture affect the legal determination of intent, or maybe a shooter's claimed competence? It seems challenging to claim a well-aimed shot when the physical conditions inherently make such a shot improbable. That could be a key point for a defense attorney, couldn't it?
It absolutely could be. It casts significant doubt on claims of precision aiming. Now, on the target side, think about the driver of the sedan.
Okay.
If their car is struck in the rear quarter panel, the driver might experience an audible impact, a loud thud or bang, but they might not immediately perceive it as a gunshot.
They might think they hit something.
Exactly. They might think they hit a pothole, ran over road debris, or maybe even got tapped by another car. They wouldn't necessarily know immediately they've been shot at. They would likely only notice the actual damage, the deformation, the paint cracking, maybe tire damage if the bullet went low later on, perhaps when they pull over or inspect the vehicle at their destination.
That's a really important point for witness testimony and reconstructing the timeline events. The target driver might not even know they've been shot at immediately.
Quite possibly not.
How does this potential delay in perception influence the timeline in a legal reconstruction, especially if investigators are trying to establish when the driver might have reacted or noticed the threat? That could be critical for assessing their actions or for evaluating self-defense claims later on if the situation escalated.
It complicates the timeline significantly. Eyewitness accounts of when things happened might be unreliable if the primary target wasn't immediately aware of the nature of the event.
Now, let's look at the sophisticated methodologies forensic experts employ to piece this whole puzzle together. What tools and techniques do they use for reconstruction? Techniques that can stand up to rigorous legal scrutiny.
Right, this isn't just guesswork, as you said earlier. It's a highly sophisticated scientific endeavor. The angle of impact on that rear quarter panel determined from the hole shape and internal path. That gives crucial insight into the shooter's relative position and maybe even the elevation of their window.
Okay.
If the bullet fully penetrated into the interior, its trajectory through the cabin could be modeled using advanced tools like 3D laser scanning.
Laser scanning, how does that work?
It creates a highly precise digital point cloud map of the entire scene, the vehicle interior, the damage points. This allows experts to literally trace the bullet's path in 3 dimensions with incredible accuracy. More traditional tools like trajectory rods are also used, of course, physically inserted to visualize the path. Forensic experts also meticulously search for trace evidence residue like lead wipe, tiny jacket fragments that may remain at the impact site or inside the vehicle along the path.
And what about sound?
Good point. If available, acoustic sensors like shot spotter systems deployed in some urban areas, or even just audio capture by dashcam microphones could provide critical timing and sometimes even distance data, helping to synchronize the entire event down to fractions of a second.
That's fascinating. What does something like 3D laser scanning bring to a courtroom that, say, simple measurements and photos can't? How do these advanced tools help establish facts that can stand up to rigorous legal scrutiny, especially when dealing with complex dynamic events like this?
They provide an objective, measurable, and visually compelling representation of the physical evidence. It moves beyond interpretation into verifiable data.
It sounds like they provide an objective, measurable basis for conclusions that's hard to argue with.
They absolutely do. And every single piece of evidence, from the precise shape of that entry hole to the internal trajectory mapping, any bullet wipe residue or deformations within the vehicle's structure, it's all critical for building a complete and accurate picture. This comprehensive approach is essential for accurate legal findings. It ensures that conclusions presented in court are based firmly on undeniable physical evidence, not speculation or subjective interpretation.
For you personally, what stands out about the sheer thoroughness required to piece together such a challenging, fast-paced event for legal proceedings? It really underscores how painstaking and detailed the work is, doesn't it? Bringing science to the service of justice.
It really does. The level of detail required and the integration of physics, materials science, and careful observation is quite remarkable.
Finally, let's consider the broader tactical implications and the associated legal ramifications of attempting such an act. What are the inherent risks of mobile shooting like this, beyond just hitting or missing the immediate target?
Well, as we've established, shooting from the driver's seat into an adjacent moving car requires highly specialized training. Training in compressed shooting positions, managing recoil in an unstable environment. It's a skill set very, very few people possess.
Right.
Attempting it without that training carries an extremely high risk of missing the intended target entirely. That's almost a given. But beyond that, there's a significant danger of bullet overpenetration.
Meaning it goes through the target car.
Exactly. The bullet passes through the target vehicle and continues its flight path, potentially for hundreds of yards downrange. And there's a very high likelihood of injuring unintended parties.
Who could that be?
Passengers in the target vehicle, obviously, but also occupants of other vehicles on the highway, cars ahead, behind, even across the median, or potentially even people off the road, entirely pedestrians, people in nearby buildings if it's urban. The risk cone is huge.
This really puts a spotlight on the enormous dangers involved. Beyond the intended target, The risk to innocent bystanders is immense. How does this inherent risk factor into legal concepts like negligence or gross negligence or reckless endangerment, even if the primary target was intended?
It weighs heavily.
It effectively argues that the act itself, given the high-speed public highway circumstances, carries an inherent and arguably unacceptable level of risk, regardless of the shooter's initial intent towards the target vehicle.
Indeed. Legally, the context matters immensely. This kind of engagement is extremely difficult to execute effectively without that specialized training we mentioned: vehicle interdiction, mobile counter-ambush, executive protection driving tactics. It's simply not a skill set most law enforcement officers possess, let alone civilians. They might train on stationary vehicles, but firing accurately from a moving one at another moving one, that's elite level.
So what does this all mean for those who do try to engage in such acts, from a legal perspective? Does the extreme difficulty and the inherent risk imply a certain level of recklessness in itself, regardless of the shooter's stated intent?
That's a compelling question for courts and juries to consider when assigning liability and determining the level of culpability. The sheer danger involved in the act itself becomes a central part of the legal equation.
Let's shift gears slightly now and really focus on quantifying the details, putting some hard numbers and visuals to what we've been discussing. First, let's revisit understanding those shallow impact angles. What precisely happens when a bullet strikes a surface at such an angle, especially from a moving vehicle in our scenario?
Okay, when a bullet strikes a surface at a shallow angle, it means it's traveling almost parallel to that surface, right? Not hitting it head on.
Like a glancing blow.
Exactly, a glancing blow. This greatly increases its chance of deflection bouncing off at an angle, or ricochet skipping off the surface, or inducing yaw, that tumbling end-over-end motion we talked about. This type of impact typically creates that oval or elongated entry hole rather than a perfectly round one.
Right.
And crucially, because it's a glancing blow, the bullet tends to retain more of its forward kinetic energy as it travels through the material or inside the vehicle body, compared to a direct hit which might expend more energy right at the surface. This can be significant for analyzing internal damage potential.
This is absolutely crucial for understanding the damage pattern and what forensic experts are looking for. What does an elongated entry hole specifically tell a forensic expert that a perfectly round one wouldn't? Especially when they're trying to establish the shooter's position and the angle of fire for a legal case.
An elongated hole immediately signals that the bullet struck at an oblique or shallow angle. It provides a clear vector, a directional indicator. In our specific scenario, remember, bullet travels left to right from the SUV driver and slightly rearward to hit the sedan's rear right quarter panel. The impact will likely be at approximately 25 to 40 degrees from perpendicular. That's measured against a line sticking straight out from the panel surface.
So definitely not 90 degrees.
No, a very shallow angle indeed, which, as we've discussed, directly leads to those elongated entry holes and increases the chance of deflection or yaw upon entry.
How precisely can an expert determine this angle from the physical evidence, from the shape of the hole? And why is that level of precision so vital for legal proceedings? Could it, for instance, disprove certain narratives or establish the exact sequence of events in court?
Yes. By carefully measuring the dimensions of the elongated hole, its major and minor axes, forensic analysts can use trigonometry to calculate the impact angle with a reasonable degree of accuracy. This mathematical certainty is vital for reconstructing the event and refuting or supporting claims about shooter position or firing direction.
And to visualize this complex geometry, you mentioned the schematic diagram earlier, that top-down view or plan view. How does that help in an investigation and in court?
It's invaluable for clarity. Imagine looking straight down from above. You see the sedan in the left lane, the SUV in the right lane. You see that approximate 10-foot lateral gap between them. The diagram clearly shows the bullet's path originating from the SUV driver-shooter position, traveling diagonally and slightly rearward to impact the rear right side of the sedan.
Visuals really are everything when you're trying to explain complex geometry, aren't they? Especially to a jury that might not have a background in physics or ballistics.
Absolutely.
How does this schematic serve as a foundational piece of evidence in a forensic report, making those complex angles and relationships understandable and maybe even undeniable?
It immediately clarifies the spatial relationship and relative positions of the vehicles and the bullet's general path. It's the visual anchor for all the subsequent calculations and expert testimony. It provides that critical starting point for any detailed trajectory analysis presented in a forensic case. It makes the abstract concrete.
Okay, this is where the science really comes alive for me, the cold, hard numbers. We've got a calculation table here that quantifies the scenario. It really grounds the narrative in undeniable physics, doesn't it?
It does. Let's try and quantify our hypothetical scenario, summarizing the key parameters we can estimate or calculate based on the setup. Assuming that lane spacing is about 10 feet, both vehicles are steady at 70 mph, and we're using that 9mm FMJ bullet with a 1,200 foot muzzle velocity. First, the shooter's lateral offset, approximately 10 feet, standard lane width difference, roughly.
Okay.
The bullet's estimated travel distance from muzzle to impact, about 13 feet diagonally, considering the 10-foot lateral and maybe 8 to 9 foot rearward distance.
Right, Pythagoras.
Essentially, yes. The impact angle will be shallow, as we calculated, likely between 25 and 40 degrees from perpendicular to the sedan's side panel.
Yeah.
The time to impact is incredibly brief. At 1,200 feet over 13 feet, roughly 0.011 seconds, just over a hundredth of a second.
Wow. Instantaneous, practically.
Almost. The expected entry shape will be oval or elongated, maybe 1.25 times wider along the direction of travel than a normal round hole. The kinetic energy at impact will still be significant, perhaps around 396 joules, assuming only minor velocity loss over that short distance. Still plenty to penetrate.
Right.
The likelihood of deflection upon hitting the curved panel is moderate due to that shallow angle, and the penetration behavior is expected to be full penetration of the thin outer metal panel, likely with minimal yaw initially upon entry, unless it hits right on a curve or internal brace.
How did these precise measurements, these numbers, help establish a timeline and a factual basis for a legal case, especially when trying to corroborate or refute witness statements? These numbers provide a concrete, objective foundation, don't they?
They do. They constrain the possibilities. And we can even do a quick trigonometric analysis, which is exactly how forensic experts pinpoint these angles more formally.
Show us.
Okay, let's assume for calculation the shooter fires at a 30-degree angle rearward relative to the line straight across, and we know the lateral opposite side of the triangle is 10 feet, and the diagonal hypotenuse path is 13 feet. We can use sine. Sine of the angle relative to the forward direction theta equals opposite over hypotenuse. So sin theta equals 1013, which is approximately 0.769.
Okay.
The angle, the theta, whose sine is 0.769, is about 50.3 degrees. Now that's the angle relative to the car's forward axis. The angle relative to the perpendicular line is 90 minus 50.3, which is about 39.7 degrees.
Right around that 40 degrees you mentioned.
Exactly. It confirms that the bullet impacts the panel at approximately 40 degrees from perpendicular, mathematically verifying that very shallow impact angle based on the geometry.
What does doing the math like this provide for legal clarity? It shows precisely how the angles have to line up, doesn't it? What is the significance of such precision in proving how an event occurred, especially when a defense might try to argue a different angle or a different intent based on a different shot placement theory?
This kind of objective calculation, derived from the physical evidence and basic geometry, can be incredibly powerful in a courtroom. It grounds the reconstruction in verifiable science, making it much harder to refute. Now, let's quickly summarize the terminal ballistics again for this scenario. What happens precisely at the point of impact on that panel?
Okay.
At that shallow angle we calculated, around 30 to 40 degrees, the 9mm FMJ bullet will likely penetrate the quarter panel. Remember, it's thin steel, maybe 0.70, 0.8 millimeters thick. The bullet might deform slightly upon impact, especially the nose, and it could deflect internally depending on what interior structures it hits immediately behind the panel, like the wheel well liner or maybe wiring harnesses or structural metal.
And it leaves that characteristic elongated entry hole.
Exactly, with likely minimal fragmentation of the bullet itself, unless it hits something really solid and dense right away.
So the physical evidence found on and in the car itself should confirm these predictions. What kind of internal damage or specific deformation would an investigator look for that would confirm these terminal ballistic effects, proving the bullet behavior inside the car and its potential threat to occupants?
They'd look for the path through insulation or liners, scrape marks on the inner wheel well, whether it struck the tire, if it hit structural components like the actual wheel housing, suspension parts like a strut tower.
What happens if it hits those?
If the bullet hits those much denser, harder structural components, you'd expect a significant loss of its energy, much greater deformation of the projectile itself, possible projectile rotation or yaw becoming much more pronounced, and consequently much less or even no penetration into the actual passenger cabin or trunk space.
This seems crucial for determining exactly how dangerous the shot actually was to the occupants.
Absolutely.
How does this affect legal considerations regarding the severity of the threat or injury inflicted? If the bullet stopped in the wheel well versus entering the cabin, that makes a huge difference in potential charges, right?
A massive difference. It speaks directly to the actual risk posed and therefore the potential severity of charges ranging from property damage up to assault or attempted homicide, depending on the outcome and intent.
Finally, let's wrap this deep dive up with a ballistic reconstruction worksheet. This sounds like the culmination, essentially the blueprint for how a forensic expert approaches such a complex case. It's like their checklist for analysis and reporting.
Exactly. You can think of it as a consolidated summary, a forensic checklist that ensures all the key scientific points required for a thorough investigation and clear reporting are covered. It would outline the scenario type, parallel highway engagement, identify the shooter vehicle, SUV, and target vehicle, sedan, note the lane separation, approx 10 feet, detail the shooter position, driver, and firing direction, left, slightly rearward. It specifies the bullet type, 9mm FMJ, and muzzle velocity, 1,200 feet. It estimates the travel distance, 13 feet, and time to impact, 0.0116. It records the impact location, rear right panel, and the calculated impact angle, 25 degrees, 40 degrees from perpendicular. It describes the expected entry wound, oval elongated, assesses the deflection risk, moderate, predicts the penetration behavior, full panel penetration, possible internal deflection, and crucially, it often includes evidence collection tips specific to this scenario, what to look for, where to measure.
For you, what stands out about the value of having such a structured worksheet or checklist when presenting these complex findings in a legal setting? It must provide a framework for clear communication, ensuring nothing critical is missed, and that the science is presented logically and is ultimately understandable.
It's invaluable. This kind of table or worksheet consolidates all those key scientific points into one easily digestible format. It serves as a powerful tool, both for training forensic specialists, teaching them the systematic approach needed, and for presenting complex findings clearly and concisely in court. It provides a robust, evidence-based foundation for legal arguments that can hopefully withstand rigorous cross-examination because it shows the methodical process behind the conclusions.
What stands out to you most about the thoroughness required to piece together such a challenging incident, and the undeniable scientific basis that should support legal conclusions drawn from it?
For me, it's the interplay between fundamental physics and the highly variable real world. It underscores that while the laws of physics are constant, applying them to a chaotic event requires incredible attention to detail and a rigorous methodology to arrive at the most probable truth. And that process is absolutely vital for justice. Hashtag, tag, outtrank, soundtrack.
Wow. What an incredible journey into the incredibly complex world of physics, ballistics, and forensic science. We've really seen how what seems like a simple act firing a gun becomes this cascade of mind-bending variables at highway speeds. From relative motion making vehicles seem static for just a fleeting moment, to the unpredictable dance of a bullet through turbulent air and complex vehicle components. It feels like every single detail matters enormously when trying to uncover the truth.
We've definitely reinforced the core takeaways today. The profound impact of relative motion, how trajectories are fundamentally modified by vehicle speed, the inherent instability of the vehicle as a firing platform, and the surprising role of those environmental variables like airflow and even road vibration. All of these factors combined make such high-speed engagements exceptionally difficult to execute effectively. And, perhaps even more importantly for our discussion, incredibly challenging to definitively reconstruct for legal purposes.
Yeah.
It's truly a testament to the fact that Hollywood very rarely gets it right.
Not even close, based on this.
Yeah.
So what does this all mean for you, our listener, when we consider the sheer unpredictability, the multitude of forces at play in a high-speed vehicle shooting?
Yeah.
What does it tell us about the burden of proof in legal cases where such events occur? How much certainty can we truly expect from forensic science in the face of such chaotic variables? Especially when someone's life, their liberty, or the pursuit of justice hangs in the balance based on that scientific interpretation.
It really invites you to consider the immense responsibility involved in interpreting such complex evidence. In a world where cinematic portrayals often simplify these events, into these clear-cut narratives of good versus evil or amazing marksmanship, understanding the scientific and physical realities underscores the profound challenges that investigators, attorneys, judges, and juries face in attributing precise causation and intent. It encourages you, hopefully, to think about that continuous pursuit of truth, even when faced with overwhelming complexity. And the critical role that meticulous science plays in trying to make sense of the chaos, striving for accuracy and fairness in the legal system.